Hi everyone. So thank you for joining us live. This is Shefden Academy. So I welcome you to this live session. So in this short training, we want to look at the introduction to Waffle Slab. So we are going to be discussing about the what Waffle Slab is all about, the types and different forms of Waffle Slab, as well as some design criteria that you have to have at the back of your mind as a design engineer if you want to design a waffle slab. So, but before we go to the full detail, I would like to welcome you to this channel. This is Shefden Academy. So, what we do here is we talked about structural design, civil engineering design. That is what we teach. So if you want to learn more about some of our things, you can check our website, chefdenacademy.com. There are a lot of free versions of videos that you can also watch from our YouTube channel. So in order to be able to deliver this class, I've prepared a PowerPoint presentation which is going to be available at the end of this session. So the first thing I would like to talk about is what do we refer to as waffle slab. So some couple of weeks ago, we've discussed extensively on this channel where I make two different kind of videos. One video is just about introduction to rib slab, and the other is design of rib slab with work example. So this was covered live just like this as well. But in today's video, we want to talk about waffle slab. A waffle slab is just another category of rib slab, but in this case, it is it has ribs spanning or running in two directions. So the difference between rib slab and waffle slab is that rib slab have ribs in one direction, while waffle slab has rib in both directions, both the major axis and the minor axis of a slab. So I'm sure you'll have seen a picture like this. So this is some example of rib slab in real life construction. So these are rib slabs. So generally, these are ways in which rib slabs are being formed. So the first thing we like to ask ourselves is why do we have to provide rib slab, or when do we provide rib slab in construction or in design generally? So I've listed some few reasons or some of the advantages of rib slab, of waffle slab, sorry, over other types of slab. We all know we have four basic types of slab which can occur in different forms. We have the solid slabs, we have the flat slab, we have the rib slab, and the waffle slab. So one of the first reason is waffle slab can be sold. So whenever I'm talking about waffle slab, the same thing can also be said for rib slab, but I'm going to be mentioning one or two ways where they differs and the differences. So when we talk about lightweight in the sense that we are comparing the weight of a normal waffle slab to a corresponding solid slab. So if your waffle slab has a overall depth of 300, comparing that with another solid slab, either solid slab or flat slab, with a weight of 300, the same thickness, the waffle slab is going to have a lighter weight because in the construction of waffle slab, we've removed a considerable amount of the concrete and we have made it void. You can see from the picture I showed earlier, we have some void and we have some part that are concrete. So those areas of void that we've removed has made the slab more uh, has made the weight of the slab more reduced and lighter. So because of that, it has a lighter weight compared to corresponding solid and flat slab. Then another reason why solid slab can be considered is that it is suitable to support heavier loads. So roof slab technically is provided where we have longer span and the live load we need to take in that kind of situation is high or is heavy. So from theory, they will tell you at least 5 kilonewton per meter square. That is when you can provide waffle slab and it will be economical. So it's very suitable for heavy load, heavy live load. And because of that, we can say it can take a longer span. That is, the difference between each support can be as long as possible for a waffle slab as compared to other types of slab like ribbed or flat or solids. And then lastly, the aesthetic advantage. From the picture I showed earlier in the introduction slide, you see that looking at the slab aesthetically is very pleasing to the eye. So that's one of the advantage of waffle slab. But I think it's important that we mention some of the disadvantage. And one of the disadvantages, it is only it make it difficult to install equipment like electrical appliances, mechanical appliances. Sometimes it might make it difficult, especially if the appliance you want to install cannot fit into the mold or into the hole that we live in. So sometimes it might be difficult to fit in these appliances sometimes. So these are some of the advantages, like just like a recap: lighter weight compared to their counterparts, heavier live load. Based on theory, they will tell you less than 5 kilonewton per meter square. At least that should be the minimum when you can say, okay, you want to go for waffle slab because it's quite expensive. And then it can take a longer span and aesthetically pleasing to the eye. So I just want to mention one or two differences, or I want to compare rib slab with waffle slab. But before I do that, if you have any question based on these sessions, you can put your questions in the comments. So I will try as much as possible to respond. You can put your questions in the comments. I will try as much as possible to respond. So let's talk about should I say the similarities or the differences between a rib slab and a waffle slab. So let me just show us some pictures. So the picture on the left hand side, this first picture is a construction reinforcement layout or settings for a waffle slab, while this is preparation construction process for a rib slab. So you can see that in the first picture to the left, the reinforcement is in both directions. So it's in both either the longer side of the slab or the shorter side is in both directions. But in terms of the rib slab, the reinforcement is in one direction. Then another major difference is that rib slab, the first one on the right, is usually constructed either by precast, because here what we have here is in situ casting. So either by precast casting or in situ casting, in the sense that the beam ribs will have been precasted, then they will just be installed on the site and then the topping slab will be casted on top. But for waffle slab, most of the time is usually cast in situ. Most of the time is usually cast in situ, that is. And then during the casting, we have mold. So all these things you are seeing here are mold. They are specialized mold. It's not just anyhow mold. They are specialized mold that they have to come from the manufacturer. So all these mold have different sizes, different depths, depending on the depth of slab you want to achieve. So it is the mold that will dictate the spacing between your ribs. So those are some of the comparison between the two. Aside from the fact that waffle slab is in both direction, rib slab is just in one direction. Then another thing you can also compare is rib slab, just like the second point that I made. Rib slab can be made with or without removable formwork. Like in this picture here, the rib slab is done with irremovable formwork, because after construction, these red bricks or clay bricks cannot be removed at the end. So it has to be permanent with the slab. But in case of waffle slab, most of the time the formworks or the mold that was used is usually temporary. So after construction or after adding of concrete, it will be removed. And another reason for this, why it is common for waffle slab, is because aesthetically, looking at waffle slab the way it is more pleasing to the eye compared to a full rib slab. And then as a final comparison, rib slab carries lighter life load based on the recommendation, is usually used for moderate to light life load. But in case of waffle slab, it can be used for heavy life load. Like I've mentioned in the previous slide, based on theory, it was recommended that it should be recommended when the life load is at least 5 kilonewton per meter squared. So this is just a simple uh, comparison between rib slab and waffle slab. Even though both of them, in general terms, we can call it rib slab, but specifically when we say rib slab, most of the time we are referring to the one-way spanning part. When we say waffle slab, we are referring to the two-way spanning part of the rib. I hope that is understood. So we have various forms of waffle slab, even though I've tried to explain it during my previous slide. So this is a form. This we are talking about in terms of support. So waffle slab can be done in two ways in terms of support. The first one is when your waffle slab, you can see that the waffle slab here is in two direction, this direction as well as in this direction. So it has rib in both direction. So one way is when your waffle slab is supported directly by beams. So this is waffle slab with beams. So the slab comprised of topping and the rib beam, which we call the waffle slab, they are now supported by beams. Then the beams will now be supported by columns. This is just like a normal solid slab support mechanism. But we also have another situation where in this case, instead of the slab being supported by beams, the slab is supported by column heads or column capital. So let me zoom in here so that you can see. So here, where we have the column, there's no beam in this situation. Where we have the column, we make that area solid, and then it will look like a flat slab system. But in this case, the slab is not solid, the slab is waffle. So those are the two major situations where you can have waffle slab. The design of all of them is quite similar. The only difference is the way you distribute the load after you've analyze and design. Where you want to design the support, that is where the difference is. And then another reason is for this second one, since it is supported directly by column, at the column capital region here, you need to check for punching shear. But for the first one, since it is supported by beam, there's no need for you to check for punching shear. Another name for this is the mushroom waffle. So you can call it waffle with column capital or the mushroom waffle. So these are the two forms of solid waffle slab that we have. Like I mentioned, generally they are usually done with removable mold. So this mold, as I've said earlier, they are of standard sizes depending on the spacing of your rib that you want. So let's now talk about design criteria for rib slab. But before we talk about that, I would like to introduce us to one of our training that is coming up. We are going to be launching it tomorrow. So it's about structural design in 3 months. If you are someone that is interested in, you want to learn reinforced concrete design from the inception phase to the project delivery phase, including sophisticated uh, structures like structures with pavements, retaining walls, and some other details. So we are going to be giving out the full details on this course tomorrow. So you can join the group. You can check the link in the description of this video. There's a link to where I put. If you want to follow us, check that link. You are going to see how to contact us on WhatsApp. So you can chat us up, and then we can add you to the class group. So it's going to be launching tomorrow, and it's going to be a 3-month virtual one-on-one personalized class. So it's going to be powerful. So if you're interested in learning design, reinforced concrete, I mean, but this class has some requirements. So you can check the flyer we put out. You see the details on that. So when we talk about design requirements, generally we want to look at some of the things that you should have at the back of your mind as the structural engineer when you want to design anything. So when we say design criteria for this, design criteria for that, these are just some of the requirements that should be at the back of your mind as engineer. So we all know, based on the picture I've showed you, you see that rib slab or waffle slab comprise of two major things. You have the ribbed and we also have the topping. So looking at this picture, this is just a simple cross section that was cut. So this is the rib. This part of the beam is the rib. So this is the rib, and then the part of the slab here is what we call the topping. So these are the two major components of a rib or waffle slab. So if you want to design a rib or waffle slab, what we are designing is either we are designing the rib or we are designing the topping. So and then when we talk about ribs is just mainly we are talking about a beam, but in this case because it is attached to the slab directly, so that's why we call it rib slab or waffle slab. We understand. And then in the case of the topping have two different scenarios. We can design the topping in two ways. The topping can be designed in such a way that the topping is contributing to the strength of the slab, of the whole slab. That's one way of designing the topping. And then we can also design the topping in such a way that it is not contributing to the structural strength of the slab. So those are the two scenarios that you can have the slab topping. So in the first scenario, which is when it is contributing to the strength, you can look at I'm going to show us a table where you can determine the minimum thickness required by the code. In this case, I'm referring to the BS code. And we know that if you talk about BS code and Euro code, they are virtually similar. So whatever goes for the BS code usually goes for the Euro code. So because of that, I'm going to be extracting the table that I mentioned in the BS code. So in that table, you see the minimum thickness for your topping. So but here you can see this is the maximum spacing allowed between your ribs. So based on the code, your ribs should not have more than 1.5 meters. That's the maximum spacing if you want to use the recommendation prescribed in the code. So it should not be more than 1.5 meters. You can see the spacing between the center line of the first rib to the second one. And then the depth of the rib beam without the topping. I mentioned that the topping can do two things. It can either contribute to strength, or you can design it in such a way that it is not contributing to strength. So the depth of the rib beam without the topping should always be less than 4 times the width of the rib beam. The width of the rib beam here, we are talking about this width. But because this rib is not giving us a perfect shape, that's why here we look for the effective width. So but if it's like a rectangular rib beam, like some of the pictures that I've showed, it's just going to be the width of that beam. So it should not be more than 4 times the width. So let's say the width of your beam is 100 mm. The maximum depth you can go for that slab without stopping is 400 mm. So that's just the application. And here you see that the topping should be greater than 50 mm. You are going to see some other scenarios where this can change. So these are some of the little design criteria you need to have at the back of your mind in choosing the rib size, the spacing between the rib, and then the depth of the rib. I hope this is understood. So if you have questions, as I've said, you can drop it in the comments. And then before I continue, I would like to mention that before you can comment, you have to join our membership program on this channel. So it is even less than $1 for you to join, and then you'll be able to have access to a lot of quality design courses or design videos on structural design. So when we now talk about we've talked about rib, we've talked about the spacing between the rib size and the spacing. So those are the requirements you have to have at the back of your mind in order to select the rib size, the spacing of the rib. Then let's talk about the topping slab. So the topping slab, as I've mentioned, whenever your topping slab is not contributing to strength, you can use any thickness that will allow you to do either any thickness that will allow you to maneuver around the slab. But generally, as designer, it is important for us to maximize our design and make it more economical, because when you design in such a way that your slab is not contributing to strength, either you design it to contribute or not, you are still going to provide a slab topping, and then we know we have minimum sizes that you can provide. So because of that, it will be wise as an engineer if you are maximizing the most economic options. So if you are designing your slab to have topping in such a way that the topping is contributing to strength, you can see the title of this table: minimum thickness of structural toppings. This is table 3.17 BS 8110 part 1. So it divides this into two categories. We have where we have permanent blocks, meaning is that, for example, in a rib slab where you have solid blocks that you use to fill in the void that is being left. So in that situations, but we know that in waffle slab, the slab is usually provided without permanent block. So that means you go for the second part of the table, slab without permanent blocks. So what the code recommend is the minimum thickness should be 50 mm or 1/10 of the clear distance between the rib, whichever is greater. So if your spacing between the rib is 400, for example, 1/10 of that is 40 mm. So that means between 40 and 50, whichever is greater is what you are going to select as your slab topping. I hope this is understood. So like I said, if you have any question, you can drop it in the comment. But before you can ask a question, you have to be a member, which is not expensive to be. Like I said, it's just less than $1 to become a member on this channel. And you have access to ask questions during our live streaming, and also have members only high quality videos on design. So let's continue with the class. So in order to end this section, I've already discussed about waffle slab, the various forms, some of the advantages, and I've also compared waffle slab to rib slab. So let us look at how you can calculate the self weight, because sometimes it might be tricky for you to calculate the self weight of a waffle slab especially. So in order to calculate the self weight, I've highlighted it in a very easy way. So let's take this example. Let's say we have a waffle slab with the size of 8 meters by 8 meters. This is the slab. So we want to design this slab, but we know before you design, you need to estimate your loads. So in order to estimate the loadings, this is what we are going to do. The first thing you have to do is to calculate the total volume of concrete. So let's say, for example, in this example I use here, our concrete is 300 mm. That is the overall depth of the slab, including the topping and the rib. The total volume is what you calculate. So when you get the total volume, we all know what the volume is. It's just area times depth. So once you get the total volume, then you now calculate the volume of void in each mode. You know, I told you waffle slab is usually constructed using mode. In the previous slide, in this live session, I've shown you some pictures. You've seen some pictures of those molds. So these molds have standard sizes. So they are usually from manufacturer. So from when you are ordering, or when you want to get the mold, you already know their sizes. You know the volume of void that each mold have. So that means that let's say, for example, one of the mold has a volume of a void of 0.8 meter cube. That's the volume of void in one mold. So you now count the number of mold you will need for your slab. Like in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 here, we have 9 here. So that means we have a total of 81 mold. 81 mold in order to achieve this 8 by 8 meter slab. So the volume of one, you multiply it by the total number of mold you need. So that's how you get this volume 2. Sorry, it's not in each. So it should be the volume of void in the total mode. So in all the mode. After you've gotten for one, you multiply by the total number of void or number of mold you have. Then you now calculate your net concrete weight, net concrete volume. This is not weight, this is volume. The volume of concrete you have. So that will be the total volume of concrete minus the volume of void. We all know this simple mathematics. Then in order to now calculate the self weight in kilonewton, we know the volume, and we all know that waffle slab is a concrete material. So you multiply the volume that you calculated, which is this V, multiply it by the density of concrete, then you multiply it by a factor, because self weight is a dead load. So you multiply it by a factor of your dead load. So if you are designing to the Euro code, you multiply it by 1.25 or 1.3. If you are designing to the BS code, you multiply by 1.4. That is the meaning of this F, the factor of safety. But you know, when we are designing slab, we don't usually design slab in kilonewton form, because slab is an area member. So we design it per area, per meter square or per meter run. So that's how we design it. So we need to convert this kilonewton load to a uniformly distributed load. So we divide the self weight in kilonewton by the slab area. So whatever we got is in kilonewton per meter run. So the reason why we say per meter run is the same thing as saying kilonewton per meter square. So because like I mentioned, we have the rib and we also have the topping. So most of the time, the topping is either designed to contribute to strength or not. So in that case, the main primary element you are designing is the rib. So you now convert this self weight to rib. You know what we have here is kilonewton per meter run. But we need, in order to design the rib slab, we need to know the amount of this part of the self weight that is going to be on a section of our rib. So that's what we are doing here. So that means the self weight is equals to this self weight here in kilonewton per meter squared multiplied by the rib spacing. That is the spacing, the clear spacing, the center to center spacing between your rib. The spacing like this. So if it is 500, if it is 400, if it is 450, whatever that spacing is, you multiply it by the self weight in kilonewton per meter square. So that will give you the self weight in kilonewton per meter per rib. That is for one section of the rib, that is going to be the self weight on it. So enough of all this grammar. Let us look at a simple example, a worked example, sorry. So let's take this as an example. Our slab is 8 meters by 8 meters, and the thickness, the overall thickness in this case, I mean the topping and the rib together, is 0.3, 300 mm. So if you do this simple calculation, you are going to end up with 19.2 meter cube as the total volume. So let's say the volume of void you have in your mold. So this is not each, it is in all the mold. Let's assume it's 8 meter cube. Like I mentioned, it can be gotten from manufacturer. So it's their standard sizes. So from the manufacturer manual, you can see the volume of void. And if it is not available, it's something you can calculate. We are engineers. So you just multiply the length, the breadth, and then the height. So this one will give us the total concrete volume, not weight. So here we have 19.2 minus 8, we end up with 11.2. So to now calculate the self weight in kilonewton, we multiply this volume by the density of concrete. If you are designing to the Euro code, you multiply by 25, not 24. If you are designing to the euro code as well, you multiply by 1.25 or 1.3. This factor, this 1.4 is the factor of safety because this is a dead load. So we have 376.2 kilonewton. So in order to convert this load to an area load, we divide by the slab area. The area is 8 meters by 8 meters. We have 5.88. But what we needed is the amount of load on one part of the rib. So that is why we assume the rib spacing is 0.75. So we have 4.41 kilonewton per meter per rib. So this is going to be the load you are going to put on your rib and analyze. So this is how you can determine the self weight for a waffle slab. In case of a rib slab, if you can check the video I made on rib slab, it's also a live video. You will see how we calculated the self weight of the rib slab. Is quite straightforward compared to this one. So technically, this will take us to the end of this section. So I've been able to discuss about what a waffle slab is. We've seen some examples. We've discussed the comparison between waffle slab and rib, and also we've talked about the design criterion for ribs for waffle slab. So if you want to learn more on this, I have a full course on it, rib and waffle slab design and detailing, not just design, but design and detailing. If you check the description of this video now, you are going to see the link to that course. It's quite straightforward. You are going to see the link to that course. It's quite straightforward. It's less than $10 to get the course. So once you get the course, you have access to full manual design for rib and waffle slab as well as detailing, and then you also see how to design them with softwares like Prota Structures. So for just less than $10 to get the full course. So I don't know, in case of any question, I will just wait for maybe 2 to 3 minutes for us to ask a question. Probably our members did not join today's lecture. So while waiting for the for the question, I would also like to remind us that if you have yet to subscribe to our channel, kindly do so. As I've said, you can also join our membership program. It's less than $1 to join, and then you have access to be able to ask questions through our live session like this, and also have access to high quality content videos on this channel. So if you go to membership, if you click on join, just below this video, join, so it will take you to how you can join, and then you see list of videos that we have already that you can start taking. And then if you're interested in learning more about civil engineering design, you can check out our website, shefdenacademy.com. We also have a lot of courses on Udemy, so you can check us out on Udemy. The link is in the description of this video. You can check it out. You see the link that will take you to our Udemy page. So in case of no question, I really appreciate you guys for joining today's training, and I hope I'm going to see you in the next one as a member, so that you'll be able to ask questions based on what I've been able to present and teach. So thank you. I really appreciate it.